ఇది బాగుంది మోడల్ వేరేగా ఉంది. లక్ష్మణ్ వాడు చించి ఎంత ఉంటుంది అది కూడా 200. నెక్స్ట్ వన్ is the advanced car finding the minimum half path. అలా వెళ్ళిపో ఎందు ఆ పైన కోట్ వద్దులే మాలో తీసుకుని 1 second. Right. Finding the minimum path by using the Edmonds-Karp algorithm. The Edmonds-Karp algorithm uses a straightforward BFS search for finding the minimum half path. అంటే ఇందులో మనం బిఎఫ్ఎస్ యూజ్ చేస్తాం. అడ్వాన్స్ సెర్చ్ యూజ్ చేసి మినిమం పాత్రని క్యాలిక్యులేట్. దిస్ ఈజ్ ఈక్వలెంట్ టు treating as a residual as an unweighted and performing a shortest path search on the following diagram. Right, here one diagram is there. The vertices are A, B, C, D, E, F, G, and there are edges are there. In this is the graph with the directed graph, and these directed graph containing the weights. Right, there are two minimum hope paths. One is the A to D and D to E, E to G, and A to D, D to F, F to G. Okay, these are the two minimum paths are there. Suppose we process the formula of these with a flow of 1. First one is the flow. This flow containing the 3 weight. And the residual, see here, the residual is here. Okay. The residual graph. Next one is the matrix computations. A matrix is a rectangular array of numbers arranged in rows and columns. Generally, matrix అంటే ఒక రెక్టాంగులర్, మేబీ స్క్వేర్ కావచ్చు, రెక్టాంగులర్ కావచ్చు, ఏదైనా కావచ్చు. array of numbers arranged in rows and columns to rows గా arrange చేస్తాం. The array of numbers below is an example of a matrix. The number of rows and its dimension or its order. By convention, rows are listed first and columns are second. Next, use of matrix computation. They are used for plotting graphs, statistics, and also to do scientific studies and research in almost different fields. Matrices are also used in representing the real world data like the population of the people, infant mortality rate, etc. They are best representation methods for plotting surveys. Matrix manipulation input A equal to Aij, B equal to Bij, C equal to Ca. C equal to A and B. It's a Cij. Right. Here there is a matrix C. Okay, obtaining by multiplying A and B. Okay, how we will calculate Cij? Cij equal to sigma K equal to 1 to N Aik into Bkj. Cij equal to sigma K equal to 1 to N Aik into Bkj. What are the standard algorithms are there? For I equal to 1 to N, do for j equal to 1 to N, do Cij equal to 0. For k equal to 1 to N, do Cij equal to Cij plus Aik into Bkj. Okay, running time big O of N cube. Is now what look? Standard algorithm for I equal to 1 to N, for 2 for j equal to 1 to N, do Cij equal to 0, for k equal to 1 to N, do Cij equal to Cij. Here there are 1, 2, 3 loops are there. For loop, one more for loop. Okay, so big O of N cube is the time complexity for this. Okay, there are 3 for loops are there. These for loops running from 1 to N. So N into N into N. N cube. Idea of Stetson's algorithm: multiply 2 by 2 matrices with only 7 recursive mults. P1 equal to A into F minus H. P2 equal to A plus B into H. So we need to remember all these things. Okay. This is the Strasson's matrix. Okay, Strasson's defines these 7 rules are there. 18 additions and 7 multiplication rules are there. Next one is the Strasson's algorithm. Strasson's algorithm uses divide and conquer approach. Divide, partition A and B into n by 2 submatrices. First, divide the matrix A and matrices into n by 2 submatrices. Initially, the matrix size is n. We need to divide into n by 2 Okay, for A and for B also. Form terms to be multiplied using plus and minus. Okay, terms మనం యూజ్ చేసుకునేప్పుడు ప్లస్ మైనస్ ఆపరేషన్స్ యూజ్ చేయాలి. కాంకర్ perform 7 multiplications of n by 2 into n by 2 sub matrices recursively. Next, combine. Perform plus and minus on n by 2 sub matrices. Combine the result of 2 matrices to find the final product or final matrix. In this context, using Strasson's matrix multiplication algorithm, the time consumption can be improved a little bit. Strasson's matrix multiplication can be performed only on square matrices where n is a power of 2. Order of both the matrices are n by n. Okay, divide x, y and z into for n by 2 matrices as represented below. Z equal to I, J, K, X equal to A, B, C, D, Y equal to E, F, G, H. Using Stressen's algorithm, compute the following things. Right, M1 equal to A plus C into E plus F, M2 equal to B plus D into G plus H, M3 equal to A minus D into E plus H, M4, M5, M6, M7 like that. Then I equal to M2, M3, M2 plus M3 minus M6 minus M7. J equal to M4 plus M6, J equal to M5 plus M7, and like L equal to also. Then the analysis of T of n equal to 7 into T of n by 2 plus dxn square if n equal to 1. Otherwise C and D are constants. Generally, what is the divide and conquer approach? Okay, generally, what is the divide and conquer approaches are there? Divide and conquer is an algorithmic pattern. In algorithmic methods, the design is to take a dispute on a huge input, break the input into minor pieces, decide the problem on each of the small pieces, and then merge the piecewise solutions into a global solution. This mechanism of solving the problem is called the divide and conquer strategy. Divide and conquer algorithm consists of following three steps. First step is the divide the original problem into set of sub problems. ఫస్ట్ మనం ఏం చేయాలి అంటే దీంట్లో ఒక ప్రాబ్లంని మనం చిన్న చిన్న పార్ట్స్గా డివైడ్ చేస్తూ వెళ్ళాలి. నెక్స్ట్ కాంకర్ సాల్వ్ ఎవ్రీ సబ్ ప్రాబ్లం ఇండివిజువల్లీ రికర్సివ్లీ. అలా మనం స్మాల్ ప్రాబ్లమ్స్కి ఎక్కడైతే డివైడ్ చేసామో ఆ స్మాల్ ప్రాబ్లమ్స్ ఒక్కొక్క దాన్ని సొల్యూషన్ చేయాలి, ఒక్కొక్కటి సాల్వ్ చేయాలి. నెక్స్ట్ కంబైన్ put together the solutions of the sub problems to get the solutions to the whole problem. Next, the problem is divided into sub problems first. These sub problems solve these sub problems. Then you will get the solution for the sub problems. Then in the combined step, you need to combine all the sub problem solutions. Then you will get the main problem solution. Fundamental of divide and conquer strategy. There are two fundamentals of divide and conquer strategy: relational formula, stopping condition. Relational formula. It is the formula that we generate from the given technique. After generation of formula, we apply D and C strategy. That is, we break the problem recursively and solve the broken subproblems. చూడండి రిలేషనల్ ఫార్ములా ఎలా చెప్తున్నారంటే ఇట్ ఈస్ ద ఫార్ములా దట్ వి జనరేట్ ఫ్రమ్ ద గివెన్ టెక్నిక్. ఆఫ్టర్ జనరేషన్ ఆఫ్ ఫార్ములా we apply D and C strategy. That is, we break the problem recursively and solve the broken subproblems. Next, stopping condition. Second one, when we break the problem using divide and conquer strategy, then we need to know that for how much time we need to apply divide and conquer. So the condition where we need to stop our recursion step of D and C called as stopping condition. Standard algorithms based on divide and conquer approach. The following algorithms are based on divide and conquer. The Stressen's matrix manipulation, techy fast Fourier transformation algorithm. Next, Kasturba algorithm for fastest manipulation, maximum and minimum problem, sorting problem, towers of Hanai problem. Divide and conquer. Following is simple divide and conquer method to multiply two square matrices. First one is the divide matrices A and B in 4 submatrices of size n by 2, n by 2, as shown in the below diagram. Calculate following values recursively: AE plus BZ, AF plus BH, plus CE plus DZ, and CF plus DH. In the above method, we do 8 multiplications for matrices of size n by 2 into n by 2 and 4 additions. Addition of two matrices take big O of n square time. So the time complexity can be written as T of n equal to 8 into T of n by 2 plus big O of n square. From Master's theorem, complexity, the above method is big O of n cube. Simple divide and conquer also leads to big O of n cube. Okay, can there be a better way? In the above divide and conquer method, the main component for high time complexity is 8 recursive calls. The idea of Stetson's method is to reduce the number of recursive calls to 7. Stetson's method is similar to above simple divide and conquer method in the sense that this method also divides matrices to submatrices of size n by 2 into n by 2 as shown in the below diagram. But in Stetson's method, the four submatrices of results are calculated using following formula. Analysis of divide and conquer algorithm. Tn equal to 8 into Tn by 2 is next to n by 2 each matrix size. Okay. Big O of n square working adding submatrices. N square times add pros of divide and conquer strategy. What are the pros are there for a divide and conquer strategy? Pros of divide and conquer strategy. Solves difficult problems with ease. Algorithms designed with divide and conquer strategies are efficient when compared to its counterpart, brute force approach. For example, if we compare time complexity of simple matrix manipulation, big O of n cube, and the Stetson's matrix manipulation, that is big O of n square. Right. Algorithms designed with divide and conquer strategy. One second. వేదండి నేను వేస్తానండి Process of divide and conquer strategy solves difficult problems with ease. Algorithms designed with the divide and conquer strategies are efficient when compared to its counterpart, brute force approach. If we compare time complexity of simplex matrix manipulation, big O of n cube, and that of Stetson's matrix manipulation, big O of n square. Third pros are the algorithms designed under divide and conquer strategy does not require any modification as they inhibit parallelism and can easily be processed by parallel processing systems. It makes efficient use of memory cache. This happens so because the problems when divided gets so small that they can be easily solved in the cache itself. If we use floating numbers, then the results may improve since round of control is very efficient in such algorithms. The most recognizable benefit of the divide and conquer paradigm is that it allows us to solve difficult problems such as the towers of Hanai, which is a mathematical game or puzzle. Being given a difficult problem can often be to go about solving it. However, with the divide and conquer method, it reduces the degree of difficulty since it divides the problem into subproblems that are easily solvable and usually runs faster than other algorithms would. Next, it also uses memory cache effectively. When the subproblems become simple enough, they can be solved within a cache without having to access the slower main memory. Okay, these are the pros. What are the cons of divide and conquer strategy? Next, cons of divide and conquer. Divide and conquer strategy uses recursion that makes it a little slower, and if a little error occurs in the code, the program may enter into an infinite loop. Next, second one, use of explicit stacks may make use of extra space. Next, if performing a recursion for number of times greater than the stack in the CPU, then the system may crash. Choosing base cases is also a limitation as picking small cases may work. If the cases are taken much higher than the capacity of the system, then problems may occur. Sometimes a case where the problem when broken down results in the same subproblems, which may needlessly increase to solving time and extra space may be consumed. Next, one of the most common issues with this sort of algorithm is the fact that the recursion is slow, which is some case outweighs any advantage of this divide and conquer process. Sometimes it can become more complicated than a basic iterative approach, especially in cases with a large n. In other words, if someone wanted to add a large amount of numbers together, if they just create a simple loop to add them together, it would turn but to be a much simpler approach than it would be divide the numbers up to into two groups, add these groups recursively, and then add the sum of the two groups together. Inverse of a triangular matrix. Computation of inverse using cofactor matrix. Properties of the inverse of a matrix. Inverse of special matrices. Unit matrix, diagonal matrix, orthogonal matrix, lower or upper triangle matrices. Matrix inverse. Inverse of a matrix can only be defined for a square matrix. Inverse of a square matrix exists only if the determinant of the matrix is non-zero. Inverse matrix of A is noted as A inverse. A into A inverse into A equal to I. For example, A equal to -1, 1, 0. A inverse, calculate the A inverse 0, 1, -1, 2. Diagonal matrix 2, 0, 0, 2 గా మార్చాలి. ఈ మైనస్ ఇన్వర్స్ డయాగనల్ మైనస్ రివర్స్ చేయాలి. A into A inverse equal to A inverse into A equal to check it 1, 0, 0, 1. It is I. Inverse of 3 by 3 matrix using cofactor matrix. Calculating the inverse of a 3 by 3 matrix is compute the matrix of minors for A. Compute the cofactor matrix by alternating plus and minus signs. Compute the adjugate matrix by taking a transpose of a cofactor matrix. Divide all elements in the adjugate matrix by determinant of a matrix. That is A inverse equal 1 by det A into adjacent of A. Next, properties of inverse of a matrix. A inverse whole inverse equal to A. AB whole inverse equal to B inverse into A inverse. KA whole inverse equal to K inverse into A inverse, where K is a non-zero scalar value. A transpose whole inverse equal to A inverse whole transpose. Inverse of identity matrices. Inverse of identity matrix is itself, because I equal to I only. Example, A into I equal to A. I inverse into A equal to A only. Suppose the matrix A equal to like this: 3, 0, 2, 2, 0, minus 2, 0, 1, 1. A matrix of minors. దీన్ని 2x2 మ్యాట్రిక్స్ మైనర్స్ గా క్యాలిక్యులేట్ చేస్తే matrix of minors 0, minus 2, 1, 1, 0, minus 2, 1, 1 ఒక మైనర్, అలాగే 2, minus 2, 0, 1 ఒక మైనర్, 2, 0, 0, 1 అనేది. ఇట్లా మనకి ఈ 9 మైనర్స్ వస్తాయి. ఈ 9 మైనర్స్ వాల్యూస్ ఇవి. నెక్స్ట్ కో ఫ్యాక్టర్ క్యాలిక్యులేట్ చేస్తాం. ఎడ్జసెంట్ ఆఫ్ ఏ క్యాలిక్యులేట్ చేస్తాం. ఏ ఇన్వర్స్ క్యాలిక్యులేట్ చేస్తాం. 1 సెకండ్. Suppose if the matrix of the site is 2x2. Suppose if the matrix of the site is 2x2. Okay, then how we will find out the inverse of the matrix? Suppose A, B, C, D is the matrix. The cone inverse is 1 by AD minus BC. 1 by AD minus BC into D, A minus B minus C. Right. AD minus BC is called the determinant. We call it as a AD minus BC as det. Then a determinant and good antam. Okay, now we want to find out the 4, 7, 2, 6 inverse. It is a 2x2 matrix. How we will calculate it? Think it. Right. See here, A means that 4, B means that 7, C means that 2, D means that 6 only. 1 by AD minus BC. 1 by 4 into 6 minus 7 into 2. Okay, D value 6 minus B. Minus B means that minus 7. Next minus C minus 2. Okay, 4. 1 by 24 minus 14. 24 minus 14 means that 10 only. So 1 by 10 into 6 minus 7 minus 2, 4. Multiply, use the 1 by 10 for the matrix. 6 by 10 is 0.6. Minus 7 by 10 is minus 0.7. Minus 2 by 10 means that minus 0.2. 4 by 10 means that 0.4. Right. Remember, it must be true that A into A inverse equal to I. Right. The value calculate this. 4, 7, 2, 6 into 0.6 minus 0.7 minus 0.2, 0.4. Then we will get the 1, 0, 0, 1. So similarly, A inverse A into A equal to I. So A inverse into A is also I. Right. Next one is the inverse may not exist for some of the matrices. Okay, 1 by 24 minus 24 means that 0. Okay, 1 by 0 means that it is an undefined value. So for this matrix, inverse is finding inverse is not possible. Okay, when it is not possible, if AD minus BC equal to 0, it means that determinant of matrix is 0, then inverse is not possible. But right, next up, how to find inverse of a 3 by 3 matrices. 3 by 3 matrices. A equal to 3 0 to 2 0 minus 2 0 1 1. We start with a matrix A and write it down with an identity matrix I next to it. 3 0 2 2 0 minus 2 0 double 1. Yeah, I is nothing but the 1 0 0 0 1 0 0 0 1 identity matrix. This is the A matrix. This is the I value. Next, add row 2 to row 1. Row 2 to row 1. Okay, then we will get this value. Next, divide row 1 by 5. ఎందుకంటే ఈ కారణంలో 1 0 0 1 చేయడం కోసం ఇది మన టార్గెట్ ఈ మ్యాట్రిక్స్. Divide row 1 with 5, then you will get like this. Next, subtract into 2. Next, inverse of orthonormal matrices. Earlier we saw that multiplication of an orthogonal matrix in its transpose results is identity matrix. If A is an orthonormal matrix, its inverse is equal to its transpose. A is an orthonormal n by n matrix. Recall A into A transpose equal to I, where IN is an n by n identity matrix. So that A transpose equal to A inverse. Okay, inverse of orthonormal matrices. Orthonormal matrices. Okay, A into A transpose equal to A. అవి ఆర్థోనార్మల్ అంటాము. ఏని A transpose. Right. Inverse of upper or lower triangular matrices. Inverse of upper and lower triangular matrices. Inverse of an upper or lower triangular matrix is another upper or lower triangular matrix. Inverse exists only if none of the diagonal elements is 0. Next, can be computed from first principle using the definition of an inverse A into A inverse equal to I. No need to compute determinant. Diagonal elements of A inverse is the reciprocal of the elements of A. Other elements are iteratively computed such that the product of the matrices is I. Inverse of upper lower triangular matrices. మెయిన్ రోడ్ లో కూడా బయట తిని అమ్ముకునే వాళ్ళు చాలా మంది ఉంటారు కదా. అదందరినీ తీశారు అంతా పన్నాడు. Right. Relations between the time complexity of basic matrix operations. A matrix is a regular or a square grid of numbers arranged into rows and columns. Each number in the matrix is called an element, and they are arranged in what is called an array. The plural of matrix is matrices. Matrices are often used in algebra to solve for unknown values in linear equations and in geometry when solving for vectors and vector operations. The four basic operations are numbers are addition, subtraction. For matrices, there are three basic row operations. That is, there are three procedures that you can do with the rows of a matrix. Basic arithmetic operations, are operation, input, output, algorithm, complexity. Addition, two n-digit numbers, n comma n. Output, one n plus one digit number. Basic addition with carry. Right. First one is the addition. Okay. Next one is the subtraction operation. Next one is the subtraction. Two n-digit numbers, n comma n. One n plus one digit number. Basic subtraction with borrow. Additional carry. Subtraction of borrow. Okay. Big O of n comma big O of log and time complexity solved. Next one is the multiplication. In multiplication, two n-digit numbers are there. Input value. Output value is the one 2n-digit number. Algorithm. Basic log multiplication algorithm is there. A three-way Tom Cook multiplication algorithm is there. A k-way Toon Cook multiplication algorithm is there. Okay, time complexity for the basic log multiplication is big O of n square. Next one. Katsuba algorithm big O of n over 1.585. Three-way Toon Cook multiplication algorithm takes the big O of n power 1.465. K-way Toon Cook multiplication algorithm takes big O of n log of 2k minus 1 by log k. Next algorithm is the mixed level Toon Cook algorithm. That is big O of n power 2 root 2 log n into log n. Next one is the division. Division, two n-digit numbers, one n-digit number. Basic long division algorithms. That is big O of n square. Next one is the square root. One n-digit number, one n Newton's method, big O of m power n. LUP decompositions. A m by n matrix is said to have a LU decomposition if there exist matrices L and U with the following properties. L is a m by n lower triangular matrix with all diagonal entries being one only. A lower upper and L ante lower, U ante upper. Yeah. Next, U is an m by n matrix in some matrix form. Advantages of LU decomposition. Suppose we want to solve a m by n system Ax equal to B. If we can find a LU decomposition for A, then to solve Ax equal to B, it is enough to solve the system. Thus, the system Ly equal to B can be solved by the method of forwarded substitution, and the subsystem Ux equal to Y can be solved by the method of backward substitution. The following examples will illustrate this. Example. Consider the given system Ax equal to B, where A equal to 1, 2, 0, 3, 2, minus 1, 1, 2, 1, B equal to 2, 8, 0. You can easily check that A equal to LU, where L equal to 0, 1, 0, 0, 3, 1, minus 0, 1, minus 1, 1. Upper triangle 1, 2, 0, 0, 0, minus 1, triple zeros. Okay, this is the LU form. But to solve Ax equal to, B, okay, we first solve Ly equal to B by forward substitution. 1, 0, 0, 3, 1, minus 0, 1, minus 1, 1. Y1, Y2, Y3 is 2, 8, 0. To get y equal to y1, y2, y3, double 2, 0. Now we solve ux equal to y by backward substitution. 1, 2, 0, 0, 0, minus 1, triple 0 into x1, x2, x3 equal to 2, 2, 0. And get x equal to x1, x2, x3. Okay, 2 into 1 minus x2, x2, 2. This is the LU decomposition matrix. LU decomposition matrix. Lower triangle, upper triangles. Right. Thank you.